Welcome back, chemistry students. We are going to be finishing up our Day 6, Unit 8 notes now, and we are going to talk about redox reactions. So redox reactions are going to round out our notes packet, and a redox is just a shorthand for a reaction that involves oxidation and reduction. So that's where we get the name from. These types of reactions, we see them represented in almost all of the reactions that we have covered so far, except for one exception, which we will talk about in a bit. But first, before we get into that, I would like to define reduction and oxidation. First up, we have reduction. Reduction is referring to the process of a charge going down. So an element, its charge is going to go down, and it's going to go down because it is gaining electrons. So at this point, it is useful to remember that electrons have a negative charge. So if we are talking about reduction and charge going down, the charge is going down because we are gaining electrons. And since electrons have a negative charge, when we gain those negative particles, we are going to reduce our charge. On the other hand, with oxidation, you're going to want to write that the charge goes up. So your charge is going to go up when we are talking about oxidation because we are losing electrons. So we are going to lose these negative particles, and our charge will go up. A very easy way to remember the difference between reduction and oxidation, I want y'all to look at the bottom of your paper here. We have this mnemonic device, oil rig. So oil rig is going to be one of two ways you can remember the difference between oxidation and reduction. So oil right here is referring to oxidation. Oxidation is losing electrons. And rig right here is referring to reduction. Reduction is gaining electrons. So you can use oil rig to remember the difference between oxidation and reduction. You can also use the phrase Leo goes grr. Sometimes you will hear it said Leo the lion goes grr. Leo goes grr is just another way to remember the difference between oxidation and reduction. Leo, you're going to write a loss of electrons is oxidation. And grr over here, a gain of electrons is reduction. So I don't care, you can use Leo goes grr, you can use oil rig, whichever way helps you best remember the difference between oxidation and reduction. And then finally, I told you that most of the reactions we have talked about are able to be redoxed with one exception, so we are going to touch on that now. I want you to draw a check mark next to every single reaction except double replacement. I'm going to put an X next to double replacement. This is because double replacement reactions are never redox. All of our other reactions can be redox, but double replacement is never redox. And this is because in order for redox to occur, an element must be by itself. So I can see in a synthesis reaction, I have elements by themselves here. In decomposition as well. In single replacement, an element is by itself. And in combustion, we have an element by itself, oxygen here. That is not the case for double replacement. So double replacement, our elements are in compounds. So they are not all on their lonesome. They are both paired up, or all four of them are paired up. So that is why we are never redox with our double replacement. So that is going to round out our Unit 8 notes. Now you need to make sure you can flip to the back of your notes packet and work on those practice combustion problems.